Good morning, class. 33 pa lang. Naririnig ba si ma'am?
Yes, ma'am.
Okay, so good morning, everyone. So today I will discuss the second process of vapor process cycle. So ito yung pangalawa, we can move on to the reheat Rankine cycle. Okay, balikan lang natin in Rankine cycle. We all know that the basic parts or the equipments that are used are basically boiler, the pressure turbine, the condenser, and the pump. While here in the heat Rankine cycle, as you can see in the schematic diagram, wherein it illustrates one stage of reheating. So take note, if we have one stage of reheating, visible din yung two stage of reheating. So mamaya, magsasolve tayo involving one reheater, one stage of reheating, and two stage of reheating. Okay. So, from the boiler, yan, makikita nyo may heat added na. So, the total heat added now is from the boiler and the reheater. Take note, from the boiler, the steam flows through the first turbine, or tinatawag natin siyang high pressure turbine. From point 1, the steam, okay, at very high pressure, at a certain temperature, superheated vapor, papasok siya dito. Okay. We have now work at the first turbine. After that, the steam leaves super high pressure, then it moves the shaft of the turbine. Automatically may produce kang work. You have produced a work. So from that, so sayang naman tas kasi sa Rankine cycle class, mababa yung efficiency. So kadalasan, ang ma-extract mo steam is pwede mo pang ma-reheat. So we make use of a reheater. Yan. So may reheater na tayo. Masok ulit siya doon. So from that point 2 to point 3, automatically, yung certain pressure natin is the same. So from that, the steam is reheated again. And after that, we'll pass through again a steam turbine wherein the turbine blades are moved, or the shaft of the turbine had produced a work. So another work. So the total work now is, we have now the work from the first turbine to end the second turbine. After that, same na ng Rankine cycle. Papasok na yung steam natin into a condenser. After that, sa condenser, may heat exchanger din yan, class. Your water is entering and leaving the system. May rejected na tayo dyan na heat. As well as from that, the condensate is being pumped again to the boiler. So, kaya nagkakaroon na tayo ng reheat Rankine cycle. So, anong dinagdag dito, class, is the reheater. Pag nagdagdag tayo ng reheater, automatically yung heat addition natin dalawa na, from the boiler and the reheater, as well as yung work ng turbine natin, mas dadami. Okay. So, here is an example of a schematic diagram. I mean, the TS diagram of or a simple one-stage reheating. Take note, if the problem involves, so from process 6 to 1, sa nangyayari yung boiler natin. From process 1 to 2, isentropic expansion to class. So, yung S1 natin is equal to S2. Yung entropy natin at a given point, from point 1 to point 2 is equal to that. At a certain temperature, if given sa problem, class, makinig, ulitin ko lang, if given sa problem na, pag hindi siya given sa problem, kino-consider siya as saturated. But if the problem involves a pressure and using the given state, so from S1 to S2, if it falls under superheated, so sa labas siya. So this is an example of a superheated state at point 2, given at an existing pressure. So automatically yung pressure 2 mo is equal to pressure 3. And Pag hindi sinabi sa problem, more likely in a reheater, the temperature from the boiler that leaves the boiler and that leaves the reheater is the same. Okay? Pag hindi binigay sa problem. Okay? That is the assumption during a reheat Rankine cycle. And from 3 to 4, again, this is now your turbine again from point 3 to point 4. So entropy, asentropic expansion, we have S3 is equal to S4. After that, from 4 to 5, dyan na nangyayari yung pump natin. So nag-fall siya sa wet region and the approximation in computing for the work of the pump at 0.5, we make use of the approximate value. Okay, and from 0.5 to 0.6, this is now your pump. Okay, 5 to 6, yes. Ay, 4 to 5 pala class yung condenser. Okay. So what is the concept of reheating here? So the concept of superheating, the steam may be reheated after it has partially expanded. So bakit kailangan ginagawa to? Or I mean, bakit ginagawa to? Para yung efficiency natin mas malaki compare sa Rankine cycle. In Rankine cycle, we always compute our efficiency ranging from 30 something, 20 plus, 20 to 30 plus. Okay. So this reaches the average temperature of heat addition by adding the heat in stages. So significant portion of the work is accomplished by the steam when the pressure is such that the steam is saturated or nearly saturated. Take note of that. If hindi given sa problem, from the point 1 to point 2, ina-assume natin, ito class, saturated yung liquid natin. Okay? So this is the correct place for the vapor to be re-superheated. So how do we compute for the work done by the turbines? So dalawa na class yung turbina natin from point 1 to point 2 and point 3 and point 4. So automatically, by energy equation, makukompute na natin yung work ng turbine. Okay? Mabilis si ma'am kasi pupunta tayo sa examples. Mag-solve tayo. After that, the work of the pump, we make use of the approximate work of the pump. And the heat added now in the cycles. So it occurs now in the boiler and the reheater. Okay? So pinakita ko lang dito yung energy equation. And solving for the thermal efficiency, we have now the general equation where it is the work of the turbine, the total work of the turbine minus work of the pump all over the heat added into the system. So, hindi na lang si boiler, pati si reheater. Okay, as well as yung work ng turbine natin from the first turbine to the second turbine. So, there is no theoretical limit to the number of reheat stages, but practically 1 or 2 used. So, otherwise, the steam exiting the turbine tends to be superheated and all of the available energy cannot be extracted from it before it reaches condenser pressure. So, take note, this is the reheat Rankine cycle. So, ano yung application natin dito? Let's try to solve. So, nabasa niyo na to, class? Okay. So, we make use of this sample problem. Okay. So, for example, the first is a reheat cycle has the following data. We have the throttle, or this is the turbine at 8.5 megapascal at 400 degrees Celsius. We have the turbine exhaust, so given pattern at 0.06 megapascal. So, automatically for an ideal cycle or ideal reheat cycle, we need to determine the work, the thermal efficiency, and the heat rate. Okay. So, ano yung isosolve natin dito, class? What is now the given in the problem? What is the given, class? So, andyan ba yung steam table nyo? Sa katabi nyo? So, given class is so this is a reheat, Rankine cycle. So, what is the given? We have pressure at point 1, 8.5 megapascal, 400. And also the turbine exhaust, or since this is a Rankine, I reheat, this is now pressure 4 for the condenser before entering the condenser pressure. So we have MPA. So always draw the TS. Use now your TS diagram. And also your schematic natin. In solution class A, yung schematic diagram natin. So, from the boiler, paliitin lang ni ma'am. So, dalawa na yan class na tutupain natin. 2 turbines. Undergo siya ng process 1. From process 1 to 2. Sa turbina natin, we have work at point 1. Nag-thundering clocks. Dede, sa buseng. And from that, the leaving steam galing sa reheater, another turbine. After that, you have now your condenser. Bilis-bilisan lang maulan. We have now your pump. So this is 4, 5. And this is now your 6. Okay. So, may heat added ka sa boiler. And may heat added ka din sa reheater. This is your reheat. Okay? May heat rejected ka dito sa condenser. So, this is the schematic diagram of reheat. So, one stage lang to class ha. One stage. Mamaya na yung TS diagram natin. Okay? So, given na natin yung parameters or the equation, the condition at point 1, we have 8.5 MPa, and the temperature at point 1, 400. So, ano siya class? In your steam table, pressure 1, table ano kayo pupunta? So, from table 2, page 12, the temperature, saturated temperature at a given pressure. So, hindi na tayo mag-interpolate. So, makikita nyo, the 8.4 is 298.49 and the 8.6 is 300.16. Nakahabol ba si ma'am? Raise your hands. Table 2, page 12. Okay. So, you have now, so automatically, so yung ranging na temperature doon sa 8.5 is from, yung 8.4 makikita mo, and 8.6. Yung temperature niya doon is 0.94 and 298 point. Ano doon si ma'am? 49, baliktad. Okay. 298.49. 300.60. So, automatically class, di naman nagre-range, mas mataas pa rin yung given temperature. So, your T1 is greater than the saturated temperature at the given pressure at point 1, automatically superheated vapor. So, saan tayo pupunta? Table what? Comment. Anong table kayo pupunta? Wala. Okay, table 3. Anong page? Okay, punta kayo dito sa table 3. Page 74. Okay? Ayan, pakita ko lang sa classmate. Table 3, page 74. Ano yung kukunin natin? From the boiler, papuntang turbina. So, that is a isentropic process. So, kunin natin is the enthalpy. So, we have now H1. This is now H1 at 400. Okay, bilisan ko na kasi magtuturo pa ako ng 2-stage. So, this is 3.1 to 8.2 kilojoule per kilogram. We have S1 which is 6.3237 Cal. Since in the problem, okay, isentropic expansion or isentropic process from point 1 to point 2, wala tayo, hindi natin alam yung sa point 2, hindi natin alam kung ano yung given parameters. Ito lang yung basehan natin, the isentropic expansion. So, saan tayo pupunta? If we have this. Take note, in the given, wala siyang binigay na pressure. So, mag-a-assume tayo. The property at point 2 at the superheated, not superheated, saturated vapor. So, anong kukunin natin? The SG. So, punta tayo class sa table 2, sa saturation pressure. Ayan, table 2. Anong hanapin mo doon? Wala tayong pressure but we make use of the the entropy part. So, hahanapin natin si S2 which is 6.3237 sa SG sa table 2. Okay, ano yung mahanap nyo? Anong parameters? Anong page? On page 12, okay? Turo ko na. On page 12, makinig. Makikita nyo sa pinaka-upper at the given pressure. So, dito tayo muna mag-base ha, sa SG. Doon ka maghahanap ng 6.3237. So, ang makikita mo sa steel table, we have 6.3318 and 6.3229. So, ang given parameters natin, 6.3237. Anong gagawin natin? Anong gagawin? Class, nakikinig ba kayo sa akin?
Interpolate po.
Okay, thank you. So, we need now to interpolate. Anong hahanapin natin dito? So, since this is, we will find the pressure in the HG. Kasi knowing that saturated vapor yung property natin. Okay? So, kunin natin lahat. So, we have 2,800.0, 2,800.5, and the pressure is 2.05 and 2.10. Sige, paki-interpolate nga. Nasaan na yung calculator ko? Sige, interpolate nyo class yung property natin at 0.2. At 0.2. Ayan, interpolate. Sige nga. Baka nakalimutan nyo mag-interpolate. So, hahanapin natin is the H2 and the pressure. Since stated sa problem, since in the problem it is not stated, yung pressure natin, hahanapin natin siya. Okay? Are you interpolating now? Ma-interpolate lang si ma'am. Minus 6.3380. Mm-hmm. 18. Na-solve yun na class. Yung H natin, yung H muna. What is your H2? Are you solving? Yung H2 natin, class. Wala. Interpolation. So, your H2 now is equal to 0.46. Okay, double check na, class. And the pressure now is ano class yung na-solve yung enthalpy at 0.2. Nakikinig ba kayo class sa akin? Okay. 2.0955. So, we make use of 2 decimals. 296. Automatically, 2 point. Yan. Gamitin lang natin tong 3 decimal. Approximately, this is now your pressure to MPA. Kasi pag yung iba class, nagsusolve pa. Yung iba nag-solve pa. Yes po, ma'am. Okay. So, since para may consistency tayo, sabi ko baga, 2 decimal palagi tayo, pero sa entropy 4. So, i-consider ko na to as 2.10 MPa. Okay? Is that okay? And yung H2 pa rin natin, yun pa rin. Okay. Para mas madali-dali. And, yan. We have now pressure 2 So, isulat ko lang yung, i-draw lang natin. So, this is now your pressure at point 1. Point 1. So, yan. Superheated yung point 1 natin, and assuming that it is saturated. So, this is from point 1 to point 2. This is now your pressure at point 2. Okay. From point 2 to point 3 class. Dito. From point 2, mag-undergo tayo ng reheat now. From point 2 to point 3. Okay? So, automatically, from point 2 to point 3, condition natin dyan is pressure 2 is equal to pressure 3. And since hindi stated again sa problem, we always assume that the leaving temperature, leaving or entering temperature at the turbine, so yung temperature 1 natin na 400, siya pa rin yung leaving temperature. So, pag ganyan class, pag hindi stated sa problem, that is always equal to that. Your temperature 1 is equal to temperature 3. Automatically, punta tayo dito sa point na to. So, we have now point 3. Okay. Ano yung condition natin para makuha yung point 3? So, at state 3, yung pressure 2 natin, ano yung constant? Constant pressure. So, ito na yung gagawin natin. We have 2.10 MPa. And the temperature 1 is equal to temperature 3. That is 400. Okay. In your table 2, the saturated temperature of 2.10 is 214. Okay. Since T3 is greater than Tsat, pupunta tayo sa superheated vapor table. Okay? So, punta na kayo class doon sa 2.10. Anong page? What page? The 2.10. Okay? So, that is now page 46. Okay? Page 46, 2.10. And, okay? 2.10, page 46. What is now the properties na kailangan natin? We have the H3. So, table 3, page 46. We have now the 210 and your guide is the 400. 3246.0 kilojoule per kilogram, and we have now the S3, which is equal to 7.1027 kilojoule per kilogram kilojoule. Again, since this is a reheating stage, balik tayo doon, nakuha na natin si S3. Papunta tayo sa state 4. So, isentropic expansion pa rin. Yan yung gagamitin natin. Okay. But, given na yung pressure natin at the turbine exhaust. So, this is now your turbine exhaust. Okay. So, ito class, diba, yung turbine exhaust natin. So, from 4, so, ito yung sinasabing turbine exhaust. So, may given na tayong pressure at point 4. So, we have 0.06 MPa. Okay? Yung pressure 4 natin is 0.06 MPa. But since from point 3 to point 4, that is also an isentropic expansion. Okay? So, yung pressure 4 natin given at 0.06 MPa. punta ka sa anong table? Table 2, anong page? 0.06. What is now the table? 0.06 class. Wala. Walang nakikinig kay ma'am. This is page 9. Ayan. Nasaan na? Duduling na si ma'am. Ayan, page 9. So, it falls under the, we have now the SG, or the entropy at that point at pressure 4 is equal to 0.06. We have 7.5320. So, anong mangyayari, class? Pag ganito, yung SG natin mas malaki kaysa sa given sa S4 natin. So, nagpo-fall siya sa wet region natin, or is mixture siya. So, mixture siya, class. Ang gagawin natin, if we have that state, yung hanapin mo. Okay? So, hanapin na natin si quality at 0.4. Okay? So, if you have now that quality, we have S4 minus SF4 over the SFG. Wait lang. Okay. So, finding the quality. Ano yung S4 natin? We have 7.1027 minus, ano yung SF4 natin? Ano po, naduduling na ako, class. Wait lang. Go there. 1.6. We have now, ilan, class? 1.1453. So, yung ano dyan, class, may calculator kayo, solve yun na, input yun na. Over the SF4, SFG, 6.38, 37, 67. Okay, what is now your quality at 0.4? Ayan. Yung iba. Same names, answering my questions. Okay. Recognize. Same names pa rin. Ayan. Naalala ko plus mga pangalan nyo. 43, 6 point. So we have now approximately 93.28. So we have 93.28%. Ano yung hanapin natin? We have now the S4. So kukunin natin si H4. Paano magkuha? Plus the quality. Yan. So what is now your H4? Considering we have the equation. So the HF now is given at, calculator nyo na to pa sa 0.86 kilojoule per kilogram plus the quality ng HF4 natin 2293.6. Yan. So we have now the H4. What is now the H4? Or the enthalpy at 0.4. So this is the property wherein it will leave now the turbine. Kaya turbine exhaust. Yung iba, 86 plus 0.9320. Okay, so lahat ng participate recorded yan last. Nare-record kung sino nagpa-participate. We have now 2499.33 kilojoule per kilogram. So, balikan natin yung ating TS para mas maintindihan. So, nakuha na natin, diba, the leaving is 0.4. So, this is now the pressure at a certain exhaust. So, pantay to class. Nagigulig si ma'am. Ayan. So, this is now your pressure 4, which is equal to pressure at 0.5. So, from state 3 to 0.4, that is an isotropic process. And nagpo-fall siya sa loob kasi nasa wet region siya. This is now your 4. 2, 3, 4. After that, Rankine na. Alam niyo na to. So, from point that, wait. Pagalaw ko yun. Okay. So, given na sa atin yung pressure at 0.4. Okay. Pressure 3 and mali lang. Ayan. So, entropy. And from 0.4 to 0.5, nangyayari dyan yung sa condenser natin. Ito. Condenser natin. So, nangyayari, heat exchange, heat is transferred. So, automatically from 0.4 to 0.5 papuntang pump. Okay? Constant pressure, and after that, yung boiler natin. At 0.6. Work ng pump, papunta sa boiler. Okay? So, what is the condition na hindi pa natin nahanap? Yung state 4. I mean state 5. Okay? At state 5, balikan natin. Yan. Pressure 4 is equal to pressure 5. State 5. Ano yun sa state 5 natin? So, pressure 5, which is equal to 0.06 MPa. Ngayon yung kukunin natin. Since yung pump natin from process 4 to 5, nandyan yung pump, we make use of the, ano yung hahanapin muna natin? Hanapin muna natin yung work ng pump in specific volume. Yung V5 natin, which is just equal to VF4. Pressure 6 minus pressure 5. Am I right? Okay, yung V5 natin, that is just equal to VF4. Kasi saturated liquid na yun. Saturated liquid. Balikan natin yung sa Rankine. So, finding for the work of the pump using the pressure at given condition na pressure 0.06. So, yung VF4 natin or yung V5 specific weight, the specific volume at saturated liquid. So, that is 1.0331 times 10 to the negative 3. And yung pressure natin, we all know that pressure 6 is equal to pressure 1. This is 8.5. 8.5 MPa. So this is 8.5 MPa minus 0.06. Paki-compute class. What is now the work of the pump in kilojoule per kilogram? Where's the calculator? Wala, saan ko nilagay? 8.72. Yung iba? Yung siya, masolve mo na ako. 8.5. So this is now 8.72 kilojoule per kilogram. So yung hanapin natin. In finding the H5, so balikan natin. H5. Tama class. Yung H5 natin, ano yung H5 natin? Since this is a saturated liquid, so this is just the F4. Ano yung enthalpy at saturated liquid? We have 359.86 kilojoule per kilogram. Tama ba ako? Okay. So, in finding now the enthalpy at 0.6, so alam natin to. So, the H5 plus the work ng pump. Then, ito pala ang equals yung ginagamit na approximate value of the work of the pump. Make use of this, 359.86. Work ng pump is 8.72. So, what is now the H6? What is now? 368. 368.58. Yeah. So we have now all the values in determining the process of this reheat Rankine cycle. But we need to determine the work and the thermal efficiency of the cycle as well as the heat rate. First is the work. So the work class is tinutukoy is the total work done by the system. So pag hindi mo alam yung equation, i-draw mo lang yun. Schematic diagram natin. 0.1, 0.2. Nangyayari doon sa una at 0.1. After leaving, you have now the second turbine. Yan, turbine blades. Work at 0.2. So, ang entering doon class is 3. Leaving is 4. So, what is now the work? The total work is of the turbine is ayan. Ayaw na magsulat. Turbine 1 plus work ng turbine at 0.2. Ano yung work ng turbine at 0.1? So, entering leaving, we have H1 minus H2 plus sa turbina natin H3 minus H4. So, finding for the work of the turbine, energy balance lang yan siya sa tandaan nyo. Okay, solve na tayo. What is H1? 3128. 2, 3128.2. Yung H2 natin, 2,846. Kayo class mag-calculator na ha. And plus H3. Mm-hmm. 3246 minus the H4. That is 2499. So what is now the total work done by the system? I mean, this is just the work of the turbine class. The total work is the total work of the turbine minus the work of the pump. Diba? Yan. This is just the total work of the turbine. Yan. Correct ko lang ang sarili. Okay? Yung iba, nagsosolve ba kayo? 0.2 minus 2,800.46. Ayan. Okay. We have now 1074.41. So this is not yet. We need to determine the work of the total work. So the total work or the work net is equal to the work of the total of the turbine minus the work of the pump. Negative kasi class yung work ng pump. Always. So this is now. What is now the work of the pump? 8.72. So this is now the work net. So we have now ilan class? Ayan. 10 point. Ayan. 1,665.69. Okay, so this is now your work in the total work. The second, we need to compute for the Kirby, the heat added. Ayan, nag-participate na lahat. So, the total heat added. So, automatically, meron ka ng si boiler natin. Papasok dun sa 6, lalabas si 1. Ayan, that alam mo yan. Added ng boiler. And meron na din tayong reheater, diba? Sa reheater class. Ano yung entry mo doon? 0.2, leaving 0.3. So, ito yung reheater natin. Okay. May heat added din dyan sa reheater. So, the total heat added is equal to the heat added by the boiler plus the heat added by the reheater. Energy equation, we have H1 minus H6 plus H3 minus H2. Ayan. So, the total heat added now, yung H1 natin na dito lang yung malapit. 3128.2 minus, ano yung H6 natin? 368. Ayan. Plus H3. May H3 tayo dito. 3246. 32 minus H2. 28.46. So what is now the total heat added by the system in a reheat? Dalawa yung class ha. So 8.2. Ayan. So we have now 3205.16. The required in letter B is not the heat added but the thermal efficiency of the cycle. Yeah. So we have now the thermal efficiency. So the work net over the heat added total. Make use of the work net 1065.69 heat added. What is now the thermal efficiency of this cycle? We have now bakit yung iba-iba? Ayan. Okay. We have 33.25% compared to the Rankine cycle. Palagi nasa-solve natin is 20 plus. Okay? So this is one-stage reheating cycle. And letter C, may pinapaanan pa pala. The heat rate class. So, sa heat rate class, we make use of this equation. Yung heat rate natin. So, general equation ng heat rate. Yan, mass natin, H1 minus HF4, or this is equal to the H5 heat rate. M1 H1 minus H5. Okay. Finding the mass. So, we make use of this 3,600 over the work net. Ayan, pakita ko lang. Work net natin, 65 point. I mean, not work net, but the total work of the pump. Pasensya, kakamali si ma'am. Mali pa ka mo. Ayan. Mali yung pangikita ni madam. Ayan. So, the total work of the turbine. Kasi andun lang yung mass ng steam natin. Okay? Ano nga yung mass ng steam natin ay work ng turbine 1074.40 and 74.41. Yan. Okay. So, finding the mass of that, automatically class unit natin is kilojoule per kilogram. Pinakita ko na kung ano yung equation natin, I mean derivation ng unit niyan. Pag ganitong heat rate, automatically ang unit na natin after this 3,600, this is the conversion factor. Automatic kilogram per kilowatt hour. Okay? So, to make use of that, we have now 3.35. Tama. And double check naman. 35 kilogram per kilowatt hour. And finding the heat rate. So, ito class yung sinasabing heat rate in the said problem. So, we have the mass. Ayan. 3.35 kilogram kilowatt hour. Okay. H1 natin. Okay, yung H1 natin. 3128.2. Tama ba? 28.2. Yung H5. Hanapin ko lang yung H5. 359.6. So, maki-compute class ng heat rate. So, this is now the heat rate. 0.2 minus the 359.6. We have 9273.94. Naging unit natin is kilojoule per kilowatt. Okay? So, this is now your solution in solving the one stage. One stage lang yan, class. Okay. Masyadong mahaba. So, the tab is now the one stage. Wala, naglalag. The one stage. Reheating. Yeah. So, this is the one stage. Paano kung dalawa, ma'am? Okay. So, another example. Yan, nakuha na natin ha. Paano kung dalawa na? Okay.